Hello, today I'll talk about semantic attention composition for text condition image retrieval. Now let us consider the problem of text condition image retrieval. In this problem, we are given a reference image. For example, a model is wearing a black dress. Along with this reference image, we are given some text feedback by a user. For example, I want the color to be similar, but the length should be longer. Now given a reference image and this feedback, we pass this as input to a text condition image retrieval module or TCIR, which retrieves results which are similar to the reference image, but they consider the feedback as requested by the user. For example, the retrieved results contain images with black dress, but they are of longer length as requested by the user in the text feedback. Now the research significance of this task is the first important challenge is to jointly model image text embeddings, which is key for any visual linguistic task. For example, we need to model longer sleeves and learn embeddings corresponding to the visual cues. Second, we also need to learn to manipulate the fine-grained image features so that we can search for the attribute specific images. For example, I want V-neck. So we need the model to understand what is V-neck and U-neck and learn to manipulate the V-neck, the features corresponding to the V-neck as well as sleeves. Now there are quite a few prior art techniques and baselines in this problem. The latest one being composite, which was published in VACWI 2021, and VAL being published in CVPR 2022. Now, coming to our approach, we break down the task of TCIR into two intuitive stages. First is where to look, and second is how to change. The first task of where to look is handled by the semantic feature attention module, and the second task of how to change we use our semantic feature modification module. So the architecture for our approach is shown. In this architecture, we have the two major modules, the SFA, the Semantic Feature Attention module, and the SFM, Semantic Feature Modification module. The SFA first learns the attention weights corresponding to the visual linguistic cues, and then uses those attention weights to modify the image embedding and the text embedding vectors in order to learn and obtain a composed embedding. So in our results or in our experiments, we observe that this type of two-staged feature learning and modification approach works quite well in practice. For more details on the architecture, please refer to our manuscript. So we perform our experiments on multiple datasets. The first being the FashionIQ dataset, which has 3 different subsets of dress, top T, and shirt images, around 10k examples each. These are some of the examples from the FashionIQ dataset. The second one is the shoes dataset, which has around 10.7k image pairs corresponding and their corresponding caption. So we have a reference image, the corresponding caption, the modification text, and the target image. And third one is the birds to words dataset. This also has around 16k examples. The major difference in this dataset is the length of captions. For the birds to words dataset, the average length of captions is quite large, as seen in the examples shown. Now coming to quantitative results, our method SAC performs or outperforms all the existing techniques on all the different subsets and the average performance as well on R at 10, R at 50 metrics. Similarly, we outperform the existing techniques on birds to words dataset and the shoes dataset as well. Now this is an example of a qualitative result from our approach where we obtain correctly labeled examples. For more additional results, both qualitative and quantitative and ablation studies, please refer to our manuscript. Thank you.